Hello, everyone. I hope this video finds you well. Today, we're going to be talking about electrophilic aromatic substitution, or EAS. And so this set of reactions is essentially all we're going to be doing is we're going to be throwing things onto benzene. We're going to be taking electrophiles that will become substituents on aromatic rings, or henceforth the name EAS. And so we're going to start off with benzene. This is your regular plain benzene. And the EAS reactions will generally proceed in three phases. Now, the first phase is going to be attacking an electrophile. So you're going to get something along the lines of this. You're attacking an electrophile. Yep. Then you're going to end up with something like this. H here, and then the E ends up right here. And so, from here, right, the next step that you're going to do, and just to quickly kind of analyze this, I totally forgot to mention this, right? There's a plus charge ends up right here, right? Because you end up taking this bond right here and you kind of remove it, right? This bond is going to be used to attack here. You end up with a plus charge here, and you end up with a E, H right here, right? The H was from just the regular H that was kind of just there, implied. And then from here, you get a base. It's going to move into here, attack this, and it's going to result in this popping back onto here. When you do that, you'll end up with something along the lines of this. E. All right. So, the most important thing you know about this is that this step from here to here is fast. This step from sorry, not fast. Sorry, I mixed it up. This step from here to here is slow. This step from here to here is fast. Yeah. Now, why is that? Right? So I want you guys to imagine a scenario for me, please. Right? So let's say, for example, you're a billionaire, right? That's like what I want to say a lot of people's dreams. I want to have a lot of money. It means freedom. They can go travel, do whatever they want, buy their parents a house, whatever it may be. And say you're a billionaire, right? So you basically are living at life. You can literally just go about your life doing whatever you want for the most part. Now, as a billionaire, right? That's like the highest status that you could achieve. If somebody were to take that away from you, right? You'd obviously want to fight that, right? If it's like a legal thing, right? If the IRS is suing you or something like that, you can fight them in court. It'll be a slow process to take away your money, right? But let's say, for example, right, after the IRS is taking away your money, now they realize, that, oh, we made a mistake, right? You'd want that money back as quickly as possible, right? Plus whatever damages that they had to pay you on top of that. And so it's a very similar situation here as to why we have slow and fast things happening, right? Because if you remember, right, benzene is aromatic. Being an aromatic molecule is like being the billionaire of molecules. It's very stable. I'm sure if a molecule wanted to, that they would love to be aromatic, right? And so from this step to this step right here, right, you're taking away aromaticity. Right. Why? Well, you're temporarily turning the molecule into something that's not flat because this is sp3 hybridized. This is all sp2 over here, and over here is sp3 hybridized, temporarily at least. So you're taking away someone's billionaire status, and so that's going to be kind of, you know, slow, right? Because the aromatic molecule doesn't want to lose its aromaticity status. But from here to here, you from next step, you're going to be uh, regaining aromaticity. Obviously, right? You want your money back, you want your billionaire status back, and of course, it's going to be fast, right? You want it back immediately. And so that's kind of the logic as to why, right? You're slow from here to here, but you're fast from here to here. The logic is that of you're losing aromaticity and regaining aromaticity. All right. So from here, I'm gonna quickly switch my notes around, and we're going to talk a little bit about some of these reactions that we're going to be doing here. All righty. So we're gonna go all the way down here. The first thing and foremost is going to be the halogenation of benzene, right? And so you need this kind of FeBr3, right, for to put a bromine onto here, and it can also be AlCl32, whichever one. All right. So let's go ahead and get started, right? So the first step from here, right, is to do some some pre-work to this, right? Br2, Br2. I'm gonna go ahead and hide this in a red color. So it's a little bit more visible for you. BR, BR, BR. Oops, not that. Right, from there you'll tack onto there. This will align to this. The Fe is very, very electropositive because there's a bunch of BRs next to it. And then we're gonna end up with something along lines of this. You're gonna end up with a plus charge here, and you're gonna end up with a minus charge here because Fe has four things attached to it. So normally, right, because benzene is so stable, it's kind of hard to get it to entice it to do a reaction. Once you form this complex, right, it makes this Br really, really attractive and forces the benzene to become a forces it to become an electrophile, sorry, a leucophile. So this is going to go into here. It's going to attack onto here. You're going to end up with something along the lines of this, right? Remember, this reaction is slow because you're losing aromaticity status. Now, since this benzene has nothing on it, it doesn't really matter where you put it because it's all symmetrical at the end of the day, right? And so you're going to end up with a Br right there, Br right there. And you're going to put the plus charge right here. It's going to be an H right here. And then from here to here, what's going to happen is that you're going to take a base, tack on here, it's going to reform. Remember, the step is fast because you're reforming aromaticity. You end up with this, Br. Yep. The mechanism for AlCl3, right? It's basically the same thing, except that instead of Fe, you have Al. Alrighty, cool. So with that reaction done, we're going to move on to nitrogenation of benzene, right? Basically, all this is that you're going to be putting this structure up here. NO2 nitro group and form nitrobenzene. Alrighty, so first step, right, doesn't actually involve the benzene just yet, right? So I'm going to go ahead, I'm going to draw out HNO3. And so you're going to get this. Okay. So the first thing you're going to do, right, is that you're going to do this. You're going to go do a quick proton transfer from here to here. This pops off into here. And then from there, you're going to, I'm going to go ahead, I'm going to redraw this. Just to make sure that you guys are kind of on the same page here. Oops. Let me make this orange. So we're going to move over this nitric over here. All right. This guy's going to have this stretch here, stretch here. And then it's going to pop down into here. This is going to push off an H2O. We're going to end up with this NO2 right here. Plus charge right here. Then you have a H2O loss up here. This H2O loss is going to be this right here. And then from here, you're going to take your benzene. Your benzene is now finally enticed to be a nucleophile. And from here, get a very similar situation over here. We have an N. There's an H right here. This comes up, slaps out of here. And you end up with this. All right, cool. And it's just a reminder, right? This step right here is slow, right? Because this step right here, right, you're losing aromaticity. And from here to here, this step is fast. Okay, cool. So we're going to move on to the next reaction, right? And all these reactions are very, very similar. We'll move on to sulfonation of benzene. All the way through here. Hopefully I'll have enough space through here. So this is pretty similar, like nitrogenation. Your first step, right? You go ahead and you take your SO3, your sulfur trioxide. Right, I'm gonna hide it there, and then this you have your sulfuric acid. I'll hide it this. This real quick proton transfer. Sorry, what am I doing here? And then from here, right? This is going to be, hold on. Sorry. This is going to be the red here. It's going to pop off. And then you're going to that's the lines of this, right? And then you'll have you'll bring in your benzene. Tack on here, this pops off onto here to relieve that plus charge. And then you have something along the lines of this. Go ahead, let me just quickly try to go as slow as possible here to avoid mistakes. And my my iPad's once again crashed. Give me 1 second. Ah, that's a high score right there. I thought that was a gunner. All right, cool. Okay, cool. Over here, and then your oh, go to race. Let's go radical. Do this right here. Then you end up with your HSO3. Let's go ahead and let's highlight this in another color, right? You have an H that's just organically on the benzene. You have your yep. Then from here, your base is going to come in. Pops up over here. And you end up with this, your end product. Or as you'll often see it abbreviated, right? Or oops, I'm just trying to say they going again. Not bad. Let's see this SO3H. Yep, sulfonation. We're gonna move on over to alkylation. So essentially, this is a very, very useful reaction because you're essentially just kind of putting on something on the line like this. I'll highlight this in another color. You're putting on an alkyl group. Customize whatever you want, right? Just make sure that you have the same carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So this is very similar to the halogenation of benzene, where you first start off right with a prep step to entice the benzene to actually go and attack. Right. As you can see here, I'm using AlCl3, right? The C, whatever you use for this part, right, has to match this, right? So this can't be AlBr and then this be like Cl, right? So end up with this is gonna attack you. Yeah. Also, I sincerely apologize for if I'm like stifling. I'm like sick, dude. So, but I gotta finish these videos. So, Cl. Plus charge right here. Negative charge right here. This is going to pop off in response. And then, oh my gosh, and I'm running out of room. Perfect. I'm gonna move that here. Alrighty. So from here, you end up with actually hold on, wait, sorry. This is probably not the right way to do it because this you end up with a plus charge on there. Let me just adjust this real quick. I'm probably going to attack this. And then attack onto here. This will pop off in response. The reason why we probably don't want to do that, like have this pop off and have this do an SN2, right? Because if we did that, right, you'd end up with something like this. Can't just treat it like an SN1 reaction. It's going to pop off onto here. This is a no-no. Don't do this. Primary carbocations are bad. If it was a secondary or tertiary carbocation, that'd be fine. You can just pop it off and treat it like an SN1 reaction. Gonna pop back on here. Or you can also use the AlCl4 right here. You can also see in the notes, right? You can use a base, generic base, or as a chapter code uses the notes, right? You could take the AlCl3 and then this can go on here, right? Okay. And from here, right? This is basically this. Yep. There's another way that you can put alkyls onto things too. And that's with the or it's not alkyl, sorry. You can put on double bonds, C double bond O, carbonyls. onto the benzene. Very, very similar process. Right. Make sure that your Lewis acid over here, right? The AlCl3, right, matches. So we have Cl. From here. This is going to pop off on its own. Oops, that's an eraser. Yep. Then when you get to this step, right, your benzene is going to come in, and then essentially it's going to initiate an attack. If you're confused, right, I'm going to go ahead. I'm going to highlight this in this color pink. And then from here, I'm going to use the AlCl3, Cl. This reform aromaticity, reform aromaticity. There you go. Gotcha. Putting the C double bond atoms onto here. All right, cool. So that's basically all the reactions that we got in this section. Hope that was helpful. And if you have any questions, please feel free to let us know. All right, I'll see you around.